everyone. I'm here with Dan, and now we are trying a algorithm-based question, combining a little bit of statistics and algorithms plus Python. And so this question is an example question that's pretty frequently asked within like the machine learning data science role. And so the question is, at least first, it's like calculate the median from a stream of integers, right? And the median is defined as like the middle value in an ordered integer list. So if the size of the list is even, then there's no middle value. Dan, how would you first kind of like approach this problem?
Yeah, so my first thought is that this does not scale well because to always have the true median, you're going to have to store every single value ever returned if we have an input stream because it could change so drastically. So I am going to start with the solution, kind of stream of consciousness here. The solution that I'm thinking of initially that won't scale, but we can tweak it to make it scale as desired. So it is a little annoying in this setup that we might have to implement our own stream functionality, but let's see how quickly we can do that.
Cool. Okay.
There we go. So I'm going to do class, and my Python is a little rusty, but I think we can work out the kinks.
We can change it too, actually, if you want.
Let's stay in Python for now. I'm glad that there's the interpreter here, so I can quickly figure out if I do anything wrong.
Okay, sounds good.
Class stream def init. Okay, so we can do self input r equals that. Self dot r equals. Let's change that to none. I don't do too much talking out loud, so if there's a clarification, please stop me.
Okay, sounds good. So you're assigning it if it exists, otherwise empty string. Nice.
Yeah.
Or sorry, empty array.
Def, and then we could do a fetch, and that returns a value. If let's just return self r dot pop. There is pop. Okay, I want to be careful about ordering, but let's keep that there for now.
All right.
Def push self dot r plus equals. Oh. Sure. Okay, that seems kind of reasonable. So def calculate median input stream. So this might have to be a class actually.
Okay.
Class median calculator.
And what's the reasoning behind the class?
Because I want to be able to say, hey, here's my stream. What's the median? And then later we're going to push stuff to this stream. And then I still want to be able to say, hey, what's the median of the stream? Gotcha. And I might, tweak things around. A lot of this is stream of consciousness, but I think we can solve this or get to what I intend to be a final solution without too much trouble. So we do need to input a stream. Self.stream. Okay. Okay, def calculate. And here's where the meat goes. Okay, so let's write some test cases. So we have stream equals stream 1, 2, 3. M equals median calculator stream. Yeah. And then we do m dot calculate. Do we have assert? Yeah, we do. Assert equals, sure. Equals the median is 2. Not a string 2. And then let's do it again, make sure it's still 2. And then stream dot push. Yeah, I like the type ahead. My IDE doesn't do that.
Oh.
Uh,
Hmm.
stream dot push 4, and then let's do assert m dot calculate equals 2.5, and then stream. Let's do it again. Why not? And then stream dot push 5, and then now the median is 3. Now let's say what are we doing? Let's say stream dot push none, and then assert m dot calculate equals none. That's how I'm going to define this. If you want to calculate the median and we don't have a list of numbers anymore,
Hmm.
just output none.
Cool.
Okay.
You got the test cases, and then that then shows if the functions are working correctly then.
Yeah, and I like to do this in the beginning so that we can align on expectations and it's nice that I do this at the beginning so that as I think of um, new
Edge cases?
scenarios, edge cases, there we go, they can hopefully be reflected in this test function.
Yes.
So I'm gonna run this. No, not start call, run. And then I expect most of these to fail. Beautiful. Okay. So the best way, so it also depends on the frequency all this stuff is happening. So if push is called way more frequently than calculate is called, we might
Mhm.
want to do a different approach. Uh, but I'm actually not so sure of that. So if push is called very frequently, then
So if push is called, then that means they're adding values from the string, right? Are coming into our calculate function. Um,
yeah, they're really staged to be calculate.
yeah, exactly. And so what if we were to calculate them at the like every single time that a new stream of integers comes in then? So like 1 to 1 on the push.
Okay. So one to one, that's feels like the simplest case. That there's no advantage to be had there. You need to insertion sort at every step to see which direction your median goes. However, you don't necessarily need to keep it fully sorted. Uh, uh,
Could you
I
explain what
wish I,
the insertion sort is, I guess?
yeah. So now we have a multi-line comment. So let's say our existing state is a sorted thing. We have 1, 2, 3, 4, 5,
Okay.
and then we do fetch. Our median is 3. So now we insert this is similar to our test cases, but I'll keep this more general. Now we insert a 6.
Okay.
So now, how do we represent this 6 into our data structure? Actually, I'm not going to do a 6. Let's do 6, 7. There we go. Now our median is 5. Now we're going to insert our median is 4. Now I'm insert a 5.5. I don't know. So now our median output should be 4.5, right? Yeah. Stop me if I make a mistake there.
I'm trying to calculate it at the same time.
So now, how might we represent this 5.5? We might be tempted to say, okay, 1, 2, 3, 4, 5, 5.5, whoa,
Mm.
5.5, 6, 7. We might be tempted to sort this in real time. So the time it takes to insert that is log n. But, geez, spacing. But we can do better than log n.
Okay.
Uh, so, so the time to insert that would be insert log n. Calculate. Our calculate time, once we have it inserted, is still O of 1. So,
Because we can just take the value that's in the middle.
exactly.
Gotcha.
We have the length, presumably as a as an attribute of our median calculator.
Hmm.
Uh, and then we can just say, give me the array value at position half. And, there is the case where it's even, and then we have to do a little bit more gymnastics, but it's still O of one. We have O of one lookup into that halfway value. Okay, but can we do better than this insert O log of n? Well, we can. It turns out we don't need to sort it completely. We don't need to do 5, then 5.567. We could say, hey, 5.5 is bigger than our current median. So just stick it on the second half of the array. We don't really care where we put it.
Yep.
This means our flush time is going to be longer, but we're okay with that. So perhaps, say option one, option two, 1, 2, 3, 4, 5, 6, 7, and maybe stick it there, 5.5.
Okay.
So we would insert that in O of one, but our calculation, uh, let me, option one, option two, the insert is now in log, or in time O of one. But what if we insert, so now we've inserted the 5.5. Now what if we insert a 2.5? So now our option one, I can count, I can do all this. Our option one looks like that. Still insert log of n, takes
Yep.
log of n time to insert into a sorted array, and still our calculate is of one. But does it work like this? Can we just stick our 2.5 there to fetch, stick our 2.5 there because it is less than our mean of 5? Turns out, or our mean of, I'm like, I'm
Of
making
four.
this a little bit more obvious. These are our median values. And
Yes.
we still have our insert and our calculate, great. But what if 5.5 ever needs to be our median? So what if, instead of inserting 2.5, we inserted a 6, let's say insert a 10, sorry.
Okay.
Making all these cases. Let's keep that as 2.5. Let's instead insert a 10 instead of the 2.5. So now we don't have that. Boom. Insert still by option one. Insert still takes O log of n.
Hmm.
Calculate takes O of one. But now we need uh, we want to somehow get at this 5.5 value. So our insert is O of one, but our calculate, how long does that take? Well, one way to do it is to first sort it by n log n. That doesn't feel very good,
Yeah.
but hey, that might be what we have to do. So, depending on the frequency all of these are called, one idea might be, hey, keep a list of all the things you've appended to either side since the last time you called calculate. That seems like a reasonable idea. I'm not going to do that for the MVP, but I think I would like to do that. So when you insert something, not only do you stick it on the end and do your gymnastics necessary, but you also include in some attribute how many times we stuck something and onto which end we did. That way, when we finally need to calculate our new median to determine whether or not it needs to include that recently inserted value, we can pop those all off and insert them as we need to, and then our amortized time still remains the best case scenario.
Okay.
So all
So
those times.
sorry to re-break it down. You're attaching them to the either side of the list based on if it's greater or less than the existing median, right?
Yes.
And then that allows us to then figure out if there's a new median value that we have to compute after we then because it's like faster because then we can just take the values off the end and then recompute.
Yeah, exactly. Anytime that our range of median changes, we would know which ones we need to insert in order to recompute.
Gotcha.
So our median is very volatile. So here our median was 5, and then here it was 5.5, 5, and then 5.5, and
Yep.
then and so on. So in order to keep your median less volatile, what we could do is keep the center of our thing, maybe the center 10 items, I don't know. This is getting more complicated than we're going to have time to implement here, but just to share what we might do in
Yep.
a more sophisticated system. We might keep the middle 10 items sorted in order. Then, whenever our median needs to recompute, because we inserted something, we might say, hey, is our median still within these 10 items? If so, we're still good. I can still report to you my median in O of one time. But if any time we've inserted too many things to one side and our median window slides over, or hey, these are our 10 items in the middle that we know are sorted. If any time that grows to, like, the window moves too much, we no longer know the true median, that's the time we need to flush and resort potentially the whole array, or maybe just the recent n items that have been inserted.
Gotcha.
So all that put aside, I'm going to implement, I think, option one because it seems foolproof and it does meet the case where it's the best case scenario anyway for when we do one-to-one insert and then give me the median.
Awesome.
So let's see how this goes. Um, so calculate self dot, let's say scene equals, let's initialize it to empty array. And then, okay, while size self return length self array, while, yeah, let's just do one at a time, sure.
Okay.
Self.stream.size greater than 0. Self.scene. Oh, let's say val equals self.stream dot fetch. That's what I called it. Great. And then we say self.insert val. Def insert self val. Let's
So while
say
the size of the stream is greater than 0, then we're fetching a value to insert, right?
exactly. So uh, print. I'll get back to that in a sec. And then once we've inserted it, self.size equals 0. Yeah, let's do that ourselves. I know we could do length of array, but I'm not sure of performance characteristics of that.
Yep.
And hey, if we can do it, whatever. Then we say, okay, if size, no, let's do it this way. Middle equals self.array self.size divided by 2. And let's cast it to an int. Yeah, okay. If self.size equals 2, other equals self.array int self.size. Let's do this. It might be an off by 1, but I'm glad I wrote some test cases to
Double check.
take care of that for me. Yeah. Then we reassign middle to middle plus other divided by 2. And then return middle. Okay. But we also want to take care of the case where you pushed me something that's not valid, like a none or a string or something.
Yep.
So let's say if self.invalid return none. Let's do this. Invalid equal, well,
Yep. So you're defining a function for valid or not, and then
I'm just going to define an attribute, and then the insert method can say, hey, if this isn't valid,
gotcha.
call everything off.
Okay.
But what might be even nice, let's just keep it that way. I was thinking what might be even nicer is what if it returned the thing that made it invalid? Like if you gave me a string, return that string as your median. But that seems too overloaded and too difficult to reason about. So we're going to keep it like this.
Okay.
So if isn't, geez, I'm going to look up in Python, check if is number.
Uh,
Uh, yeah.
there's a string that is
Instance
digit
of.
function, yeah, or
So
instance of.
I want to only care about if you handed me like a what's it called? A integer type or a float type instance. How do I Python check if is number?
Let's assume they're all integers, actually, because I think that's actually in the question too, is that they're all
Okay.
integers. Yeah.
Well, to pass my test cases is none self.valid equals false. Return. If not self.valid. So I'm returning early. If we're not valid, stop. It kind of goes outside the scope of the problem, but I don't know. It's a nice bell and whistle, I guess.
Yeah.
Okay, so let's do the base case. If length array equals self.array. If length array is 0, then self.array.push append val and then return early. Okay, great. Is that what I want to do? Maybe that's not what I want to do. Maybe I want to do self insert helper 0 length of self.array and val. Insert helper self start stop val. Great. So now I'm implementing a helper function. So we're going to do binary search for where this value goes in our median thing,
Gotcha.
median calculator. And the more I'm writing this, the more I'm realizing, hey, like it would be much better to not have to keep this whole thing sorted. But I think it's for the sake of speed of writing this and getting a MVP out, I think this is the way to go.
Yep.
So if, well, start equals stop, then we know our value needs to be inserted there. Okay. So self.array equals self.array until start plus val plus self.array stop. Stop. And there might be an, they're equal anyway. There might be an off by 1, but I'm glad I have test cases to check that. Okay, so, and then return. Okay, if they're not equal, then I want to find out, which side it goes on to. So let's say middle equals self.array. I find myself rewriting code from above, so maybe I want to put that into a helper function. Equals start plus stop divided by 2 int. Okay, but I'll maybe condense, not repeat myself later, but for now, here's what we got. So notice I don't care if it's even or odd. I'm
Yep.
just casting it to an int. Okay, if val is less than middle, something. Well, if val is less than middle, then I know it needs to go in the bottom half. So I could do insert helper self start middle val. Else insert helper self middle stop val. Whoa, self. This might work. And then another thing I'm thinking of that it doesn't scale so, oh geez, come on, Python. It doesn't scale so well because we have recursion here. So that could probably be, implemented out. But for our simple case, we won't hit a Stack Overflow. I'm gonna see if there's anything I'm forgetting. Okay, sweet. Greater than not equal, oh, because we're in Python, not JavaScript like I've been doing a lot recently. What line is that, 57?
Yes.
That's why I'm grateful to have, a CoderPad interpreter rather than having to whiteboard this and then, not being able to do that. Okay. Whoa. Didn't I? Oh, that's why.
Mm.
Actually, is that why? Why self.stream is stream?
Isn't it just self dot size?
No, because I want to fetch the size of my stream.
Mm.
Oh, but I've duplicated my length. So the size returns the length. That might be what I want. Okay, a little bit better. Middle is equal to that. Great, and my insert helper. So maybe I do need to do the base case. Darn. Okay. If should it go here or below? Maybe it should go below. If start is stop.
Start equals stop, then self array less than start.
As I do insert, let's print. We're in Python 3.
Yep.
Python 3. Yep. Print self.array and value. Yeah. I think we're making it past the first one and not to the second one. Sweet, we are. Okay. So interesting. This is an off by one error. Okay. Insert helper. We're almost there. Ooh, interesting. Why is stop making it up to size 3? That is very interesting to me.
So calculate is being called.
Oh, duh, because the middle, I want index, not the value at middle. I've made that mistake before. Okay, progress. We've got everything inserted.
I think the assert, these might be commas in the function, but I would double check that actually.
Okay,
For
thanks.
assert, let me just check.
I think we're getting what I want. Let me see. I could just do assert true, right? Okay, sweet. So now after I've inserted print self.array. Actually, let's just do it down here. Middle and index. Okay. Why is index 0? Because self.size divided by 2. My size is 3, so 3 divided by 2 is, well, int is 1. So I'm surprised that my index is, because I'm not incrementing size. Self.size plus equals 1. Now it might work. Ooh, there's some recursion. Exactly what I was afraid of. Okay, let's stop this there and see what happens. Because I'm not sure where it's dying because of that ugliness. Okay, well. It won't tell me. Okay. Let's say depth. Well, if depth greater than 10, return print full return. Sure. Okay.
So this is to show you how deep you're going in the recursion, right?
I'm just gonna bail out if the depth gets more than 10, great, so that works. Let's say print impossible, and then start, stop, val. I want to find out why is it recursing so frequently.
Mhm.
Impossible 2, 3, 4, and I also want to do self.ra. Okay, so the start is 2, the stop is 4. Because we're inserting a 4, so it should go at the end. Okay, so here's an instance of my off by 1 error, perhaps. Oh, okay, so start, stop, 2, 0, 1, 2. How is stop getting to be, oh, do I want this? Do I want this? No, that can't be right. What should I do when I insert at the end? So we should say, does it go in 1, 2, 3? Then we say it goes in the top half. So we say,
Mhm.
okay, 2, 3. And then we say 2 and 3. Okay. Ooh, okay. So I think it's here. I think it might be here. I might not want start, I might want index plus 1 because of this halfway business.
Mhm.
Darn. Okay. um, after, when calculating, I want to do this. Yeah, middle index. Ooh. Index is 2. Ooh, maybe I want -1? No. Is this even happening? I'm not sure. It is not. That's because you're never gonna get mod 2 equals 2. Okay, I think this is what I want. Hey, okay.
Wait.
Hmm? So my issue was, I don't know why I thought mod 2 equals 2. That's odd. And this, I guess, could be is or whatever. Great, passes all my test cases. This one, why is this the case? I would expect it to be +1. Because if my index is 2, or my length is 4, so my index is 2. Oh, because the length, okay, so the length is 4. So that means the index is 2, but we have 0 indexing. So I have to do
Yep.
-1. Cool.
Yep.
I
Awesome.
like reasoning about my off by 1 errors when my test cases fail, rather than scratching my head about it for longer than I might need to.
Yeah, and I
Uh,
think it kind of showed how you debugged it as well, which was super helpful, right?
yeah,
Going in and adding the depth and then printing out exactly where the error was occurring.
yeah, yeah. So that's, definitely a shortcoming of the recursive approach as opposed to the iterative approach.
Yes.
But recursive is definitely easier for me to grok about. And what's nice is, we can test this thing, and I like to build quickly to something testable and then find out why it doesn't work. Because not only does that make sure my testing thing works like I expect it to, because I don't expect it to work on the first try,
Yeah.
it also gives me an opportunity to fix all those things as I'm still writing it.
Awesome.
Yeah.
Cool. Thanks, Dan. This was great.